So this morning we will cover chapter 3, expressions and interactivity. We kind of did some kind of interactivity in the last class on the lab that we had, and we will see its explanation of it and more details of the scene object. The mathematical expressions, data type conversion, typecasting, overflow and underflow, named constant, multiple and combined assignment, formatting output, working with characters and strings, using C strings, and then more mathematical library functions. So the scene object is a standard input object, like cout requires the IO stream file in the header, used to read input from the keyboard, often used with cout to display a user prompt first. Data retrieved from the scene with 2 greater than sign. Input data is stored in one or more variables. The scene object, user input goes from a keyboard to the input buffer where it's stored as its characters, and then the scene converts the data to the type that matches the variable. You have the int height, so cout, how tall is the room, and then cn height. Of course, you have to declare it the height, and then before you can actually say read it from the user. It can be used to input multiple values, so you can say scene height and width. So multiple values from the keyboard must be separated by spaces or enter. So must press enter after typing the last value. So multiple values need not only be of the same type, but order is important. So order is important. First value entered is stored, then in first variable, and so on. An expression can be constant. Yes.
What happens if someone types
You can create complex expressions using multiple mathematical operators. Example of mathematical expressions are 2 height a plus b divided by c. These are expressions similar to what you have learned in math. Using mathematical expressions can be used in assignment statements with cout and in other types of statements. So examples would be area equals 2 times pi times radius, and then the output would be border is, and then whatever that you pass is another way you can pass a variable, an expression like that. Okay. Order of operation, similar to what you have learned in math. So you do the parentheses first, and then you do the unary negation or negative in order left to right, and then multiplication, division, module in order left to right, and then the plus and the minus in order left to right. So here's an expression, 2 plus 2 times 2 minus 2. So you first evaluate the multiplication, and then you evaluate the plus sign, again left to right, and then the third expression. So here you have parentheses can be used to override the order of operation here. So here, once you put a parenthesis in, then you have to work with that. Okay. And then times 2 minus 2, and then the multiplication would happen first. So that would be 4 times 2, and then minus 2, which would be 6. Okay, but if you write it like that, then you have 2 plus 2 times, then 2 minus 2 first, you have to work with that. So that gives you a 0, then 2 times 0 is 0, then you get the 2 out. Here, 2 parentheses, this gives you a 4, and this gives you a 0, so 4 times 0 is 0. Here, you do the multiplication, the middle is what you start with, 2 times 2, which is a 4, and then you can say 6 minus 2, or say 4 minus 2, which is 2 plus 2. Either one is fine, or 6 minus 2, which is 4. Algebraic expression, so multiplication requires an operator. So here you have area equals LW is written as area equals length times width. There is no exponentiation operator in math. So what you do is the power. So area, power, S comma 2. Okay. Now to use the power requires the CMath header. Instead of include IO stream, you will also need include CMath. Okay. Parentheses may be needed to maintain order of operation. So if you had the equation of the slope, m equals y2 minus y1 divided by x2 minus x1, you would write it like this. And you would do the same way if you had to write this in a TI-83 or 84 calculator as well. Operations are performed between operands of the same type. So if operands do not have the same type, C++ will automatically convert one to be the type of the other. So this can impact the result of the calculation. So this is hierarchy of data types. What do we say data types are? We talked about it last class. What are data types?
Data.
Huh? Say it again.
Data.
A lot of data, you said?
No, collection of data.
No, what is a data type?
Piece of information. Formats in which information is stored in.
The type of information that you're storing in, right? So we'll talk about the type of information you're storing, or type of information. You can say type data. It says data type, or you can say types of data. Does that make sense? Variable is the temporary storage where you hold it, right? So you have the storage place, you can hold it, but the data type is what type of information you're trying to hold. So this is the highest to lowest. So we have long double, then you have double. Then you have float, you have unassigned long, you have long, unassigned int, and then you have int. Okay? So this is ranked by the largest number they can hold. We have what's called type coercion. So coercion, automatic conversion of an operand to another data type. So promotions converts to a higher type, so demotions converts to a lower type of the hierarchy that we have just seen. So coercion rules, so character short unassigned, short are automatically promoted to an int. So when operating on values of different data type, the lower ranked one is promoted to the type of the higher one. So when using the equal sign or the assignment operator, the type of expression on the right will be converted to the type of variable on the left. So if demotion is required to use the assignment operator, so the stored result may be incorrect if there is not enough space available in the receiving variable. So floating point values are truncated when assigned to an integer variable. So coercion affects the values used in calculation. It does not change the types associated with the variable. So we have what's called typecasting used for manual data type conversion. So format is static cast and then whatever the data type is and then the value. So an example of that would be cout static cast int 4.2. So we are converting this into an int. It was 4.2 is float, so we're converting this into an int, so it becomes 4. In Java, you don't have to do this part. You just say int and then put the numbers. Some more typecasting examples. And then auto typecast style. So you can have double volume 21.58, then let's write this int volume 1, volume 2, or you can say int volume. So this is a C style when you write it like that. When you write it in a function style, it would be the pre-standard C++ style cast. Okay, so you have C style cast is the prefix notation, and pre-standard C++ cast uses functional notation, static cast, the current standard. You have overflow and underflow. This occurs when assigning a value that is too large, which is the overflow, or too small, which is the underflow, to be held in a variable. So the variable contains a value that is wrapped around the set of possible values. So the compiler gives you a choice on how you handle these. It may display a warning, error message, or display a dialog box and ask what to do. Or it will ask you to stop the program, continue execution with the incorrect value. It's also called named constant values. So variables whose content cannot be changed during the program execution. So these are constants, like for example, tax rate, used for representing constant values with the descriptive names. So here you can say constant double tax rate, or constant int number of states. Okay, and often uppercase letters are used. So what are the benefits of named constants? It makes program code more readable by documenting the purpose of the constant in the name. So you have constant double tax rate. Make sure, like we talked about the variables, when you define a variable, make sure it reflects what it's trying to do or what it's trying to hold. Sales tax equals the purchase price times the tax rate. It simplifies program maintenance. Constant double tax rate, and then you set it where it's equal to. You also have define, which is the C star, define num state 50. So interpreted by the preprocessor rather than the compiler. You don't need a semicolon when you use the define. So it doesn't occupy a memory location like a constant variable defined with a constant. Instead, it causes a text substitution to occur. In the above example, every occurrence in a program, num state will be replaced by 50. You're allowed to use multiple times the assignment operator or the equal sign. Associative, you can associate the right to left. Okay. And you can use combined assignments, what's called the augmented assignment, augmented operator. So this would be plus equal to, minus equal to, multiplication equal to, division equal to, the module equal to. It's also called a compound operator. And some more examples of those. So the right-hand side is evaluated before the combined assignment operation is done. You can format an output. You can control how output displays for numeric and string data, whether it's a size, position, number of digits. However, for you to use it, it uses the IOMAN IP header file. That's where you have the IO stream. Then you have what's called stream manipulators. This used to control features on output field. So some affect just the next value displayed or set width, set W. And then you pass a variable x, let's say, print a field that's at least x times y. It will use more spaces if specified field width is not big enough. So you have int x 10, num equals 256. When you try to print this, you're saying give me a space of 10 and then put these numbers in that space to the right. Okay, you start from the right and then going back left to the numbers. Okay. And you can look at these examples on your text. You have significant digits or precision, total number of digits that are displayed before and after the decimal point. So some affect values until changed. So you have set precision x when used with fixed, print floating point values using x digits after the decimal. So without fixed, print floating point value using x significant digits. So fixed, use decimal notation, not E notation for floating point values. You have show point, always print in decimal for floating point values. And you have some examples that you can look at, and you can use left, right justification values. So these are some examples. Again, when you see these examples, try to copy it and then just run it, just for practice purposes. Okay? Especially from your book. The book uses enough examples, especially the one that was referenced in the text. You can work with characters and strings. Character holds a single character, a string holds a sequence of characters, like we have seen last class. Can both be used in assignment statements, and both can be displayed with the cout and the less than sign. String input, reading a string object, you can have declared string str, and then you can read that. Okay. So here's a string with no blanks. What happens if John Doe was entered? So you can use the get line sin and string. So reads a string that may contain blanks, and you can compare with the examples that you will see in these pages. So some character input that you can look at. So if you sin ch, it will read non-blank character. Sin.get ch reads any character. Ch equals sin.get reads any character. Cn.ignore this function skips over the next character in the input buffer and so forth. You have some string operators. You have the assignment assigns the value to a string. So here you have string words and then words assigned to the word taste. And then you can use the plus operator to concatenate, combine two words or more. So here you have a string S1 equals hot, S2 equals dark. So here you have S1 plus S2, and then it would give you food equals hot dog. And you can concatenate a string into another string using augmented operator. Okay. You have string member functions. These are built-in functions to give you a length, the number of characters in the string. An example of that. So you have a string first press George Washington, and then int size equals first press that length will give you the size. Okay. Assign is built-in function. Put repeated characters in a string can be used for formatting output. Again, when you go through the solo learn, it shows you some examples of these. Practice those. When you're doing solo learn, it comes with an example of try this. So click on that and try it. Okay. So using a C strings. So C string is stored as an array of characters. Programmer must indicate maximum number of characters at the definition. So constant int size equals 5. So character 10 size hot, and then it uses the last space as a null character. Program must make sure that array is big enough for desired use of temp can hold up to 4 characters plus the null character. Creating in the C string, you can use this constant int size 10 and then character. You pass it like as if it was an array. So you can say sin get line C string and then 10. Create C string that may contain blanks. Okay, ensures that it's less than or equal to 9 characters are read. Okay, sample program, you can use that. You can also use set width and set w and width to control input field. C string initialization versus assignment. You can initialize something to whatever value you want, or you can assign it left to right. Okay, it's another way of doing it. So, however, C string cannot later be assigned a value using the equal sign operator. You must use the string copy function. So you cannot do this, but you can do this to string copy it from one month and then the value you want to assign it to. You can take it from the keyboard. Must use sin.getLine to put the keyboard input into a C string. Note that the sin.getLine is not equal to the getLine function. Okay, it must indicate the target C string and a maximum number of characters to read. So there are some built-in math functions that you can use, but again, any of these, when you're trying to use, you have to add your header CMath. Instead of include IO stream, you use include CMath header file. So take double arguments and return double commonly used functions at absolute value, the sine, the cosine, and all the trig functions, the logarithm, okay, and the power or exponent. So you can use some more math library functions, including random number. So returns a random number between 0 and the largest int the computer can hold. And it will yield the same sequence of numbers each time the program is run. So try some of these examples. S1 is initialize a random number generator with unsigned int x, which is the seed value should be called the most ones in a program. And then some more random numbers. You can use time to generate different seed values each time that a program runs. You can use include seed time needed for time and so forth. So some more examples you can look at. All right, so last time we did some input and output, right? So in this session about sin, let's initialize some numbers. Let's say we say int x. And then maybe ask the user to enter a number. And then how do we read that number?
CN.
So we would use CN, right? And then we call it whatever variable that we have defined, right? And then here we can say you have entered. Then here we print the value that the user entered. Right? So we can run this program. Let's enter a number, 5. Say, oh, you have entered 5. Easy, right? And maybe we can use what we did, kind of like the augmented operators that we have seen. So if I say x times equals 7, okay, what do you think this would give us?
7. Oh, x equals 7.
Okay. Huh?
X equals 7.
Would this give us x equal to 7?
No.
So what does this give us?
The number times 7.
Huh?
The number times 7.
The number what?
The number entered times 7.
Just tell me the answer. What does this give us?
5.
Huh? It would give us 35 because this is augmented, right? We are saying whatever this is, multiply it with,
X.
okay? So here we can just put in x if we wanted that, okay? Or make it better, put in a slash n, and then actually say what we are trying to say. X times equal to 7 would give you, and put it like that. Okay. So enter a number. How about if I enter 7? What would I get?
49.
49.
And if I enter 9, and it gives you 60. Trying to see how your arithmetic. All right, so it would give you 63. You see that? And we can change this whether it was division, whether it was addition, and so forth. Okay. If this was plus, what would it give us? And it depends on the number I enter, right? So enter a number. If I say 3, okay, this would give us what? There. See that? Okay. So this was what the augmented was. And all right, any question? Your first project is basically reading from the user and doing a conversion like that. You declare some values, like kind of like we initialized it, and you convert that value, basically multiplying, dividing, whatever you're doing with that, and you're submitting that. So here in this lab, on page, this is the past ocean levels. You submit the solution. Just use the link. Once you saved it, just use that link to submit. So you basically taking an input from the user and then converting that, doing some conversion. Basically, you're saying this equals that, and you're multiplying, and then you're just doing the output. Okay. And then make sure you document your code. Don't just submit it. Make sure what the program's about, your name, the date. If you want to get full points, if you describe each one of these, not all of them, but at least the essentials in your program. Okay. So again, when you're submitting your assignments, you're submitting either this PrepIL link or you're submitting the link for Solo Learn. Okay. And if you decide to do it in Solo Learn, you're submitting the code playground. Okay. And within the code playground, you pick a new code and you pick C++, and that is, and then you log in. That's the link you submit. Okay. So you have a choice to submit it through Solo Learn link or you submit the link in here. Okay. And make sure you don't fall behind on the tutorials that you're going through. All right. So I'm not sure why this one is not loading. Okay.
There's only one submission.
I'll say it again.
There's only one submission. Is there only one submission?
No, you have 2 chances. 2 chances if you submit ahead of time. Okay. So you pick C++, and then after you have done your work, you save as, gives you a name, you copy that link, and that link is the one you submit here. You press lab 1, and Here, you submit that code. Like you copy it, and you submit it right here. Like that. Okay?
Does it have to be just that, or you can do a text editor, so you do a text editor?
No. You're submitting this link from Solo Learn, or you're submitting the link from Replit. This is it. Yeah. Okay? Thank you.